Hey guys, so I'm back with another problem. This time we want to given a linked list, so this is our linked list, right? So for any given linked list, we want to receive a node. So let's say for example we are receiving this node in our function and then just remove it in place and do not return anything, and then make the changes be applied to the linked list that was passed into us. So what we essentially want to do, as we said before, is that to remove the node that is passed to us along with its pointer, and then update the previous pointer to point to the new node. But since we are only given this node, and this is a single linked list, we do not have access to the pointer of the previous node. So how are we going to tackle this, and how are we going to remove this node if we can't update the pointer from the previous node? So we have to start getting creative here, and we have to think of what is this pointer pointing to, because we can't change that. This is there, and we don't know if even a previous node exists or not. Although I can say that for this function we have to suppose that we are not given the first node nor the last node. Okay, so we will only be given one of these middle nodes, and we won't know what's before any node that we're given. We have to modify the linked list in a way that after running our function, the linked list is changed. So if someone prints the linked list, they will see a new linked list. So you have to start get more creative here, and let's say we are passing this node over here. So we don't have access to any of these previous nodes or pointers. And so essentially this pointer is pointing to the node that we are modifying. And the node that we are passing is basically an address in memory. So what I'm trying to get to here is that maybe we can store what's inside this node and put it inside this node, so that whenever the memory tries to read this place, they will read the data from the next node. So we're not removing this node completely. We're keeping its place in memory, but we're updating its data. And then we can also update its pointer and get the pointer from the next node and put it inside here. And if we had any other nodes after that, we had to update the pointers and places of those nodes as well. Or not? No, because once we, let me change colors to illustrate this better. Say if I pick another color like red. So what we are essentially doing is that we are keeping this place in memory, and we are storing this pointer inside, storing the value of this node inside this. So we're basically moving this to here, right? So we're overwriting the original data. And again, we are getting the value of this pointer and storing it inside this pointer, so that this pointer now points to this node. Okay, so that's what the pointer means. Like the pointer, the data of the pointer is actually the tip of the pointer, that it's the object that it's pointing to, not the direction or stuff like that. So it's not a vector, it's a pointer. It's pointing to something. And if we what happens when we grab this pointer and put it somewhere else, its direction and everything could change on our diagrams. So if we, like, for example, put this pointer here, it essentially gets like this, right? So it's always pointing to this object wherever we put it, okay? So now we want to grab that pointer and put it here. So what that means is that this node now points to this node. So both its value and its pointer are updated. And essentially what we did was that, and the rest of the linked list works just fine. Like the value and pointers of these continue to represent the rest of the linked list. And what we essentially did was that we grabbed the data from the next node of the node that we want to delete, and we put that inside the node that we're passed in and we want to delete. And after that, we basically preserved the place of that node in memory, but we lost the place of the next node that we had in memory, but we kept its data. So we're basically putting the data inside here, right? And again, grab another color for better illustration. So what we did was that we grabbed the data from here and stored that inside this. So data, but we lost the place of this node in memory. So if the circle is the place, we lost the place of this node in memory, or the address is a better term. But we kept this pointer, and we also we got rid of this pointer, and we got rid of the data inside this node as well. So what we are basically removing are the data inside the node that we're passed in and its pointer, but we're keeping its place, and we're keeping the data and the pointer from the next node, but we're we're basically not doing anything with the place of that next node. And that allows us to, I know it sounded a little bit complicated, but I think you got the whole idea. And what that allows us to do is to remove that node, remove the node that we're passed in by removing its data. Like we are faking removing it, and then we are regenerating the rest of the linked list. And to regenerate the rest of the linked list, we basically need to regenerate this. We need to fix this part, these two nodes only. So again, to recap before we dive into the code. So this is the linked list. Right? We will not be passed in the first node or the last node, so we're safe. And we will get a node from the middle. Like let's say, for example, somebody wants to remove this node and they pass it to our function. What we will essentially, like let's even pick another node. Somebody wants to remove this node and they pass its address or the circle that I drew around it to our function, and what we do inside our function is that we will remove its data and after removing its data, it will grab the data from the next node and put it inside our the node that they want to remove, and then we will remove the pointer of that node and replace it with the pointer from the next node. So I point to this. And essentially this node and its pointer will also get lost in memory, so we are kind of removing that. And our new linked list would look something like this. So we're skipping the next node, but we're preserving its data and pointer. Right, I hope it makes sense. Now for the Beagle of runtime complexity of this, I would say it's O of constants, because no matter how large the linked list that we passed in is, we are always going to modify only the next node, and we don't care actually about the rest of the linked list. So I would say it's O of constant. Right, so this is the runtime. So let's dive into the code and implement this. Right. So this was a linked list that we created in our previous examples, and we created our own custom linked list node class. And I basically walked through all of these methods and fields in a previous video, so if you're interested in that, go watch Welcome to Linked Lists videos, especially part 1, where I explain all these. And now let's see how our linked list looks. So I'm going to call our linked list node class, and then call the print method off of it, and then pass the first node of our linked list to it. So if I save this and run this, we will get a linked list which is like this. So node 1 has a value of 2, and it's pointing to node 2. And node 2 has a value of 5, and it's pointing to node 3, and so on until we reach to the tail of our linked list, and its data is 5 and it's not pointing to anything, or it's pointing to null. So this is the head of our linked list, and this is the tail of our linked list. And for our function, we won't get passed in either head or tail. We will only get past some node from the middle. And so yeah, I'm just going to add another print before our linked list, and I'm going to say before, and then I'll maybe add another print statement with some dashes. Then we're going to say after. So if I run this, this is our after. I need to add a new line. Or maybe I can just have that new line inside our print method over here. So if this is that, or else, so if we reach the last node, we will want to print this, right? So if I run this, yeah, that's much better. I'm going to add a little bit of these dashes. Just a little bit more, and yeah, we're good. And I am basically going to print the linked list one more time, since we're not editing, we're not returning anything, and we just have to do this. And I'm going to call our function here, right? Now let's define our function before main in our class. So I'm going to say it's a public function and it's static and it returns nothing, and I'm just going to call it remove node, and the data that we're expecting to get passed in is of type linked list node, and I'm going to call it, how about just node. And then inside the body of this function, what I'm going to do, so I'm going to basically grab the data from the next node. So we always know that there is a next node because we are not expecting to get passed in the last node, which is the only node that doesn't have a next node. So there is always some data to the next node. So I'm not going to check for any errors in this case. So I'm going to say n.data equals or gets n.next.data, right? So n.data gets, or sorry, node.data gets node.next.data, and what else? So n.next, which is its pointer, and is assigned to n.next. So I'm going to say node.next. So the pointer of the node that we're passed in is going to be the pointer of the next node. And I think that would be it. Let's call our function here and see if it actually works. So I'm going to call remove node and pass it in, how about node 4? And then run this function to see how it works. Yeah, that was basically it, right? It's working. Let's see. So node 4, we tried to remove node 4, which is this. So 258 and then 5. 258 and then 5. Yeah, so we removed that. Now let's try another one, maybe node. Let's get near to the edges. So node 2. How about node 2? Let's run this again. So node 2 was 5. So yeah, we don't have that anymore. Node 6. How about node 6? Let's run this again. Yeah, that is removed as well. We don't have this anymore. Now, just out of curiosity, let's see what happens if we remove the node 1. Oh, we were able to remove the node 1. That's cool. That's a unintentional feature to our code. So node 7. Alright, node 7 throws an error. So we can, there's only one node that there's only one condition that throws an error, so maybe we can handle this one condition. Maybe we can say if n.next was null, or sorry, node.next, then print out something like don't pass the tail, and And let's run it again. All right. So we're getting this along with the error. Maybe we should also return all those functions. Is that a thing? Can we return from return with nothing? Yeah. Don't pass the tail. That's good. Okay. So I'm going to stop it here. I think we understood the idea and concept behind this function. It's really simple. This is the main part of the function, but yeah, this is only for error handling. So if you like this video, please like it and stay tuned for more coding challenges. And yeah, I will see you in the next one.